Hi friends, this is Pradeep Kumar here. This session I am starting for Network Simulator 3. Already I have some lectures on Network Simulator 3, NS3 introduction and NS3 installation. You can please refer my video, refer my channel youtube.com/ts Pradeep Kumar, or simply you can search it for Engineering Clinic. So this is my YouTube channel. So I have already have a NS2 tutorial series of totally 21 lectures. You can verify that. So time permits, I will update some more lectures also on NS2. But so many people are asking for Network Simulator 3 to be the tutorial. Why can't you give NS3 tutorial like that? So that's why I am here in front of you for giving a NS3 tutorial. So this could be tutorial series number 3 because installation and introduction, if you already seen it, this could be the lecture tutorial number 3. To begin with any network simulator, the users have to consider main things. One thing is the source code, or we call the APIs. Where do I refer? How do I start? Where do I start? That is what the main question everyone will come across. So these first few lectures of NS3 will focus on mainly on how do you start, where do you start. If you are already an advanced user, you may skip this lecture, or if you want to get more details about Network Simulator 3, you can follow this lecture. So one thing is source code API. The advantage of NS3 being you can use Python or C programming. Python or C++. You need not bother that, like in NS2 we have TCL and C++. Here we have to use both TCL as plus C++, but in NS3 we can use either Python or C++. So it's an added advantage that if your cycle is only on Python, you can refer Python. If your cycle is only on C++, you can simply bother about C++. So in these lectures, though I know Python a bit, but I will be preferring only on C++ because I have learned C++ right through 20 years of my career. I use C++, so I prefer to use C++ for this complete lecture. If you are strong in Python, please you can follow it. Okay, so how to begin with? Where do I start? That's what everyone question. So I have been doing this Network Simulator 2 for the past 10 or 12 years. I have done so many protocols, so many packets, so many agents. I have created so many applications in Network Simulator 2. But all these things, when I started, I struggled for installation. I struggled for more than 6 months. I roam here and there to get information. That time internet is also not very popular, so I need to ask for individual researchers for installing this Network Simulator 2. But when I start NS3 2 years back, so I felt NS3 was so comfortable and it was so easy for me to adapt to it because of the source code and the libraries and the support which NS3 gives. So NS3 have a wide support across the globe, so you can get so much amount of support here in NS3 as well. Okay, now where do I start? How do I begin? How to begin with this and where do I start? So everyone, they wanted to do some networking research. They take some topics like sensor networks, wireless networks, and even nowadays people take IoT, then peer-to-peer networks, then CSMA networks, etc. So people usually select networks like this. So most of the simulators, they may not support all the protocols directly. So but some means they support some kind of protocols in wired and wireless networks commonly. NS3 also have the similar thing. NS3 adopted so many protocols from NS2. So the NS2 libraries were imported to NS3, like AODV protocol, DSDV, TORA, this kind of protocol they have directly imported from NS2 to work with NS3. So the source code is completely redesigned to cater to the needs of this Network Simulator 3. Okay. Now NS3 NS3 gives some examples to start with. NS3 usually gives some examples. So one example is first.cc, second.cc, third.cc, then fifth.cc, sixth.cc, and of course seventh.cc. They have given these many files in a folder called as example/tutorial. So this is the first starting point when you are starting NS3. So even if you are if I conduct a 2-day workshop, a full 1 day will be going only for this examples. So you need not replicate all the examples. One or two examples I can tell, so you can able to work on the remaining examples. So that's how we have to start our simulation. So in this work, I'll go for first.cc. So let you understand what really CAD takes about first.cc. It is nothing but peer-to-peer network. Peer-to-peer network means a node. Assume this is a node and there is another node. So how packet is exchanged between these two nodes? That's what peer-to-peer network. So this is how this network is going to. So how to write a code for this network? How the code is written for this network? That is what this entire topic on about. But not only that. So after I write the code, now suppose the code is freely available and it's already available. I'll explain the code line by line. You can understand it. After the code, what next? So NS3 have so many thing called as NetAnim. So NetAnim is a tool called as network animator. Then it is having a tool called as visualizer, and it has a tool called as Wireshark. So Wireshark is a third party for packet analyzer. Then we have trace format called as trace metrics. That's a software here. Then we have flow metrics. I think flow metrics or flow trace. Let's see flow metrics. Then like this, we have so many third-party softwares or that software that comes along with NS3. So we can able to use all these softwares in a particular given example. That's what we are going to see. Okay, in this example, what we see is we will use NetAnimation or visualizer, and we use trace metrics, we use Wireshark. So how we use all these four things in a single source code of first.cc. So I am going to take an example called as first.cc. Okay, I'll tell you the compilation steps also, how to use, where to use. Okay, so usually the folder structure in NS3 works this way: ns hyphen all-in-one hyphen 3.27. I am taking an example of 3.27. So in case we are supporting 3.28 or 25 or anything, so you can use accordingly. So this is the place where we have all the examples available. The tutorial example, the first level of examples available in this location. Okay. For this is for source code location. So source code example location. Okay. Okay. How to run? All these files, these .cc files have to be put inside the folder called as, I will put this folder ns-3.27/scratch. In this folder you have to paste the .cc files for running its execution. Okay, how to run? The command is, I need to go to this folder. Suppose I am in home folder, ns-all-in-one-3.27/ns-3.27. so I am inside this folder. Afterwards I need to use /waf /run scratch/first, no extension. So no extension of .cc here. To run Python files, again you have to copy in the same folder. Afterwards /waf /pyrun scratch/first.py. This is how we have to do. Okay, so ns3 first.text. I store this file. I will copy this in my channel in the description also. You can download this if you want. Okay, now we can see in the terminal. I am in the terminal here. So let me go with my home folder. So this is my home. You can check it. Hecko $home. This is my home /Pradeep Kumar. Here I can see I have ns all-in-one 3.27. so this is my example I have. So what I do is cd ns hyphen all-in-one 3.27 then cd ns 3.27. okay, so this is the location. You can see there is a place called as examples. So cd examples and you have example. There are so many examples there. Energy related codes will be there, IPv6 codes will be here, naming will be here, routing will be here, statistics, traffic control, UDP, wireless, UDP client server, tutorial, TCP, socket, real time, matrix topology, error model. All these source codes are available here, freely available. You can use these examples. So assume that which area you are working, accordingly you can select the particular files or folders. Okay, now in my case I am going to use this folder tutorial, cd tutorial. Here I have these first level examples to run: first.cc, fifth.cc, first.py, fourth.cc, second.cc, seventh.cc, third.cc, second.py, sixth, like that. We have so many files. So what I do is I'll just copy this first.cc into the scratch folder. Okay, so either I can go through GUI using Control C, Control V. So let me, if you want to do the same thing, let me do that. So I go inside NS all-in-one 3.27, then NS 3.27, then examples, then tutorial, then I will copy first.cc. So copy first.cc. Then I go to NS 3.27, then there's a folder called scratch. I copy it here. I already have used it, anyway I'll just replace it. Okay, so first.cc has been replaced here. Please see that whenever you do any changes, do inside the scratch folder, don't do it on the tutorial folder. It might throw some errors if something is wrong. Okay, so now again I'll go inside this folder. So as per this command I will be running this example now. /waf /run scratch first. No .cc extension. Please see that .cc is not there, and we got the output. This is how the output shows. This is only text output. At time 2 seconds, client sent 1024 bytes to this IP address port number 9. At time 2.00369, the server received 1024 bytes. At the same time, the server sent another 1024 bytes to the 10.1.1.1 port number this. Then the client received, after some time, the client received the bytes. So that means a client and the server communication between two different nodes is happening. Now we will see what is the source code of it. I use gedit scratch first.cc. So to open this file, we have this, and first they have some comments here. Okay, so now we have include files. So include core module.h, network module.h, internet module.h, point-to-point module.h, and applications module.h. There are so totally 5 header files have been imported or included. So these header files are already part of NS3, so they have been included here. Now we are starting our program. So okay, so using namespace NS3. So this is the first level. You would have seen in C++ we will be using namespace std. So that means every object name or every class name, whenever I can use a command called as std : or scope resolution operator and the name of the function I will be using. Similarly, most of these libraries belong to NS3, so I am using NS3. Then NS log component define, first script example. So if someone read your code, we have to have a documentation example. So in the documentation, what we do is usually a source code, it's responsible for providing documentation too. So this some data will be recorded to the documentation. So here it shows you it is a first script example. That means the first script that in NS3 when you are learning, this is the script you have to refer. That's what here. Next thing is integer main. We know that the main always C command, C programming, C++ starts with a main. So we have a main. Here we have argument count and argument vector. Okay, we will come back later. What is this about? So command line command. So we can use a command line also here. So we are parsing this argument count and the argument vector. So usually the argument count and vector, what happens is usually the output variables are being passed in the command argument in the command line. So number of arguments 1, 2, 3, 4 like that, and what is each and each argument vector. So how to pass the output variable name. So for that we use argc and argv. So that is been passed here, and now we have time. You can see here time : set resolution. Okay, so that means here set resolution, the time : ns means is nanoseconds. So we will be setting our time resolution to nanoseconds. So the speed of network will be in the nanoseconds. Then log component, here we have log component define. The definition of the log is first script example. Here the log component, what component we are going to use? We are going to use UDP echo client and UDP echo server application. That's what we are going to use. So this is for perfectly, it is for the documentation. Okay, now we bring in node container nodes dot create of 2. Now these are the functions which are already been written inside the core module. So accordingly, first level is node container nodes and nodes dot create 2. So node container, it's like something like a box where the variable name is nodes which are contained in the container, and nodes dot create of 2. So we are going to create two different nodes, so two nodes. So as per our example, we'll be creating two nodes. For example, the same 0 0 I have written here. Yes, this is how we are going to have two different nodes here. Okay, so maybe in my next lecture I will show you graphically how we are going to write it. I don't have the device now, so possibly I will next lecture I will let you know. Then next thing is point to point helper classes. Actually refer to my introduction to NS3 lecture. There I have given 5 different entities of NS3: nodes, applications, channels, topology helpers, and net devices. These are the 5 different things available here. We use nodes, channel, net device, application, and topology helpers. These are the 5 different things that anyone have to learn. So anything is depend on application will be net devices, networking devices, and channel, and then nodes are simply computers. So point to point helper, it's a helper class now. It is preferably on the topology helper classes. I am creating an object called as point to point. Please remember, it's object, the naming the object is very important here, because whenever we refer to any variable name, we will be referring to their object names. So point to point helper, point to point. You can see the naming reference. This is the class P in uppercase letter, T in uppercase letter, and P again in uppercase letter, H in uppercase letters. This is a class name. Whereas object name, the first letter always starts with a lowercase letter P, but afterwards each syllable, the first letter will be uppercase. Okay, so this way. So this point to point, maybe if you want, you can use P2P also. Nobody stop even doing it, but since it is an already available example, I just maintain the same variable names. Okay, now point to point network means it is a wired network where there is two nodes are connected in a single Ethernet line. So if it is a wired network, we have to define only two parameters. One is the data rate, another is the bandwidth. On what speed the data move, how much amount of data moves. So that's what here. So point to point at set device attribute, data rate, string value 5 Mbps. That means 5 Mbps is the data rate, and delay will be 2 milliseconds. So the total data will be 5 Mbps, that's a bandwidth, and the delay will be 2 milliseconds. Every packet moves at a speed of 2 milliseconds. Okay, now node creation is done. Second thing is net device container. So net device is something like NIC card, we can say. NIC cards is simply called a network interface card. Network interface card. So these kind of cards, usually when you purchase a motherboard, the motherboard has with a patch card. So Ethernet working device will be coming separately. You just attach the card into the motherboard so that your motherboard is enabled with networking. That is called as net device. So how can I simulate such a hardware into a software? That's what NS3 does. So here we have this NIC card. So in this NIC card we call as net device container devices. So I am going to create a device. Now device is equal to point dot install nodes. So what I do is, here I have created the variable name nodes. Now these devices are being installed on the nodes. That's mean what? Assume the nodes are motherboards. Inside the motherboard, these devices are being attached. So that's what here we have devices equal to point dot install. Then internet stack helper. So now next thing is internet stack helper. Now after that devices attached, nodes are created, devices are attached. Now I need to connect. In the network connectivity have to be given. So I need to set IP addresses. I need to find out how do I get the internet. All these things I need to do. So for that I have internet stack helper. Again another helper class. As per the helper class, here we have a variable name called as stack. stack.install on the nodes. So that means over and above the nodes, we install the networking stack. That means once you have the networking stack, we can allocate IP addresses, then we can make it to the network, and we can use internet connectivity on that. Okay, now we use internet IP version 4 address helper. So in case if you want to do your work on IP version 6, you can use it here, but this example shows you IP version 4 here. So IP version 4 address helper address. So it's a variable name again another helper class with the variable name address. Address dot set base 10.1.1.0 255.255.255.0. So you know this is a subnet mask, and this will be the IP address starting range. It is a base. Base means you can see usually in IP addresses we never use the first address. First address means anything. Suppose here it is 10.10.9.0, we won't use. We will be using starting from 1 up to 254, and even 10.10.9.255 also will not be used because it is mainly for broadcast, the last address 255. So we always use from 1 to 254. But what is the basis? What is the first address, starting address? That's what here it is 0 and it is 255. Okay, next thing is IP version 4 interface container. So now it is interface container, as we see in Linux IF config. This is called as interface config. Now it will tell you what are the interfaces your machine have. My machine have ENP1S0, that is Ethernet, nothing, no IP address. Then local loopback, I have 127.0.0.1, and VMnet, there is a virtual machine, so that address, and VMnet 8 also same thing. And here is the wireless. I am using wireless. My IP address is 192.168.31.254. See that last address it is used. Okay, and this address is broadcast. See, broadcast always uses last value is 255. Okay, so this way 255 is been this address interface container. This is called the interface container. The name of the variable is interfaces equal to address.assign devices. Now please remember, the devices is the object name of the network devices. It is not on the nodes, it is on the devices. So these devices, the addresses are assigned on the network devices rather than the nodes, because above the nodes the devices are attached. Okay, in these devices we just allocate the address base. Okay, now UDP echo server helper, echo server. Okay, now server and client application. So what is a server client application we usually do is server will open the port. The client should know the port of the server, and the client will access the value via the server, through the server via the port. That means a server will be located with the port number open. Okay, this port number is 9. So let me use, for example, I will use 3689. That's a port number I will use. For example, I will take some random port number. So for your information, there are totally 65,536 ports are available in a computer, in a networking device, any networking device. Even your computer have 2 power 16 ports. That's what we call 65,536. Sorry, I have to remove one. Yeah, 65,536. Almost the value is 2 cap 16. That is 2 power 16 ports. Among that, up to 1024 port, port number 1 to 1024 we never use it because it is already reserved for some other purpose. Beyond 1024 it's freely available to use any port number. Okay, so now in this case, since it is simulator, I can use any port. So UDP echo server helper, echo server 3689. I am going to use the port number 3689. Okay, now I need to start the server. Okay, there are 2 nodes now. Now here application container server apps. Now I am going to create a new server. Now you can see application nodes we have seen, net devices we have seen, helper classes we have seen. Now we come to application container server apps. The name of the variable is server apps. Echo server means this is the echo server variable name. Dot install. Where do I install? Nodes dot get of 1. So I have created totally 2 nodes. The first node is referred by node of get of 0, and the second node is referred by nodes dot get of 1. Okay, so I'll use first node. So please make this as your reference. First node is referred by, and second node is referred by this node dot get of 1. Okay, now we can understand nodes dot get of 1 means it is referring the node number 2. So always the node index starts with 0. So we will be having two nodes and the node index starts with 0. So I am using get of 1. Now server apps start 1 second, stop 10 seconds. Here what happens is I am going to start the server at 1 second and stop the server at 10 seconds. So totally the duration of the server on time will be 9 seconds. 10 minus 1 will be 9 seconds. Okay, now server side is over. Now I have to use the client side. UDP echo client helper echo client. Now here we have is echo server. Now we use echo client here. Interfaces dot get address of 1. Now we can understand interfaces mean how many interfaces. So first nodes interfaces dot get address. That means they get the address of the node number 1. That means first node is node number 0, second node is node number 1. Get address of 1 means the node number 1, they get the interfaces. Which port number? The client has to know the port number of the server. So the port number is 3689. As per the statement, you have to change it here. Okay, now the client set the attributes. So maximum number of packets is 1, interval 1 seconds, and packet size is 1024 bytes. U integer value means unsigned integer value, because packet size cannot be in negative, so we should go for unsigned values. Okay, now application container client applications echo client dot install nodes dot get 0. Now what we do is the server is installed on get of 1, where the client is installed on get of 0. So that means the client is installed on the server number node number 0. Okay, now the client is starting at 2.0 seconds and the stop it by 10 seconds. Please remember, the client should start only after the server is enabled. So I should not start the client by 0.5 seconds, because the server is starting only by, for example, if I do like this, the server is starting only by 1.0, but the client is trying to access the server, which cannot be possible. So I can use 2.0 here. Then simulator double colon run and simulator double colon destroy, return 0. Okay, now we'll be adding some more extra codes into this network to show you how the network animation works, how the tracing works. All these things we'll be seeing. So before that, I'll run the simulation again. So I'll clear the screen and I'll run the simulation again. You can see the command is, and I'll write it again, /waf. /waf means you can see there is a file called as WAF. I want to run this file. The WAF is in the current folder. I want to run this. So / refers to current directory. Within the current directory, there is a file called as WAF _run scratch first. Enter. Once you enter, it will start building it. If you give any error, it will throw you the error. Now you can see at time 2 seconds, client sent 1024 bytes to 10.1.1.2 port number 3689. But please remember, we have set the base only. The IP address allocation is handled by NS3 itself. We didn't give any .2 or .1. We didn't give. Automatically, the global address helper have handled the IP addresses. It will create IP addresses and alert to the nodes. So at time 2 seconds, client sent 1024 bytes to this via port number 3689. And at 2.00369 seconds, the server received 1024 bytes from this node. So client node is 10.1.1.1, server node is 10.1.1.2. Client port is 49153, whereas server port is 3689. And at the same time, when the server sends another packet to the client back. The client receives, after some time, the client receives the 1024 bytes from the port number 3689 from the client. Okay, so this is how it works. Now we will see how this thing works for a visualizer or a network animator. Okay, so now what we do is, I will implement network animation here. I want to see the animation of this network. So I am going to add a code for network animation using the software called as NetAnim. See the value here. NetAnim is NetAnim. N is capital letter and A is capital letter, uppercase letters. So I need to use that. So what I do is, first I include #include then double quotes ns3 slash netanim hyphen module.h. Already this module is there, you can simply going to use this module. Okay, so include ns3 slash netanim hyphen module.h. so this I need to include it here, also you can include it. Okay, so after that everything has to be, most of the code should be running above this function simulator colon double colon run. So above this function we have to do all these things. After this I use animation interface and I create an object and I want to create a file name called as first.xml. so it is based on XML file, so I create a file called as first.xml. the name of the file is first.xml, so I use it. So in case we found any name, we can use that. Then anim dot set constant position. Actually this command is not needed, but anyhow to make it for wireless network, this command, because we need to make the wireless node to stay in a constant position, that's why. Since wired node are already staying in the constant position, you may get a warning, but don't bother about the warnings. Okay, so nodes dot get of 0. so what I am going to, where do I go to place the node number 0? so let me use 10.0 comma 10.0. I use value 10.0 comma 10.0. similarly the second node, set constant position nodes dot get of 1 comma 20.0 comma 20.0. so don't give the same value, so that both the nodes will be overloaded. You may not know which node is lying. Okay, sometimes we forget things and we do. Okay, so now my animation interface code is done. Now I need to execute this code. Please see that now there's a separate syntax for it. This you have to take care. So let me go to the last. To run this file, the same line. So let me do that first. Later I can come back. So dot slash waf double hyphen run scratch first. So I'll be running this example. Now see that you will get some mobility model issue. Constant position if it is stationary. It is giving a warning that use set constant position if it is stationary. Warning node does not have a mobility model. So don't bother about this. It's only a warning. So no issues. And I am getting the output. Now I will check the file name ls. You can see that the file called as first.xml is created. So this file only we wanted. Okay. Okay. Now I will come to the NetAnim folder. Here you can see NetAnim is a folder comes along with NS3. So it is available at cdns hyphen all-in-one hyphen 3.27 slash, I'll show you here, cd space dot dot, and you can see that's a file called as NetAnim hyphen 3.108. for every version there may be a change. So this is, you can see here this folder. So here this folder I have a file called as, in green color you can see that's a file called as NetAnim. So this file I can able to run. Okay, dot slash, usually dot slash NetAnim. Please remember, even in this way also you can install a software, sudo apt install NetAnim. This way also you can install a software, but this software have various issues in executing the NS3 files. So please do not download this software. Instead use this NetAnim software. Okay. So in case if you get any errors in NetAnim, because so many of the people may not get this file, so they may get error. In case if you get any error, use this software. Sudo apt install qt4 hyphen default, then qt4 hyphen qmake. Okay, so after this statement you use this, then afterwards qmake netanim.pro, then make. So this is the command for installing netbook animation in case if you have any issues. Okay, but anyway I have done everything. Anyway for your example I'll just try it out. Sudo apt install qt4 hyphen default qt4 hyphen qmake. So I have already installed it, so no issues in that. Then qmake can see netanim.pro. So use that. After that, give a make command, you will get it. Anyway, fine. So now I will be using /netanim. So now this file, this window get opens, and here in the top left you can see open menu. Here we are going to open the XML trace file, but before that we can see two different tab also. One is statistics, another is packets. So we can able to see some graphs also here. Let me show you. Animator, open it. Here in NS 3.27, because we have run the example in NS 3.27 only, here you can see the first.xml. So usually students, what they do is they say they create XML file in one folder, they will be searching in some other folders. So we usually run all the examples in the folder number NS-3.27. So I'll double click this. You can see it's showing a random location here, so you can maximize this using zooming window. You can zoom it, but our simulation is at 10,10, so there will somewhere it should be here 10,10, 20,20, it should be here. So when I run the simulation, it comes. Okay, and you can see there's a fast simulation, slow simulation. I'll go to the slowest one. Sometimes fast you cannot able to check. The number of lines 5, node size is 1, something like that. So node size, let me use bigger nodes. Okay, so node size, let me use 5. Now you can see this is the arrows play animation. Now you can see the animation. Yes, now node 0 is a client node sending a packet to the server. You can see the time axis here, and the node 1 receives immediately, it sends another packet to the node 0 at this time number. You can see, in this flow simulation I am seeing it. So this is the first animation that I can able to view in NS3. Now we come to the statistics. You can see node 0, what is the IP address, what is the interface address, the local interface, and IPv6 also it is there, but nothing is there, and the MAC address there, and node 0, what is the other node. So just some information about this. And packets, here the packets you can see, since it is a simple network, so node 0, node 1, it sends a packet here, afterwards it receives and sends a packet back here. So this is how the information source. And even you can export this table also. Since it is only 2 nodes involved, you can get only less number of things. In some applications you can get the complete thing. You can export as a table and store it in a text file. So this way you can able to do in the network animation. NetAnim. Let me close this because we have done the simulation. So yes, now the next software what I am going to install will be the trace matrix. So now NetAnim is done. Now next thing is trace matrix, which is based on ASCII trace format. So what this ASCII trace format will do is, will create a trace format in a ASCII file. So this ASCII file, okay, so this ASCII trace format, it will print the logs in the ASCII format. That's what it is. So how to include this inside a C file? So let me use that again. I'll be using everything above the simulator function. Okay, so ASCII format tracing. So ASCII trace helper, there's a class called as ASCII trace helper. Since I already know this command, so I am just directly using it. In case if you are doing for the first time, you please remember this command. So ASCII dot okay, to which object of this class you are going to trace. So now here I have only one helper class called as point to point helper. So this is a point to point node, so I just copy this variable name or object name and I paste it here, point to point dot enable ASCII all. Okay, so enable ASCII all. Now here what I use is ASCII dot, slightly complicated, but once you understand you can easily create file stream. This is the syntax, and name of the file is let me use again first.tr. So first.trace file I will be using. So what I do here is ASCII trace helper ASCII point to point dot enable ASCII all ascii dot create file stream first dot tr. So it will create another file called as first dot tr. Already it will create a file called as first dot xml. Now this will be creating another file called as first dot tr. Okay. Now this again I will run it. /pub double hyphen run scratch first. So every time I am running, every time I am typing again and again to make you remember things. Okay, now it is done. Now I can check the ls. Now here there is a file called as first.tr. Now I'll open this file. Now this is how it looks like. See that plus means enq, node number, it is 2 points, time number 2, time 2. What is the name of this node? Node is 0, device list 0, point to point net device, transition queue, enq, PPP header, there is point to point header, P2P protocol, IPv4 header. So complete information about this thing, and the payload of 1024 bytes that we have specified. Next line is again plus is enq, minus means dequeue. After minus there will be always or, because after the queue is dequeued, after the from the queue the packet is moved to the receiving end. So that is a receiving. Again plus, again minus, again or. So that's how from the server to client it happens. Okay, so this trace file, how do I trace it? So we have a file called as software called as trace metrics as we see. So first before installing that you need to install Java. So what you do is default -jdk, use this command first. It needs Java. Okay, so download the trace metrics software from this location. So you can use this location. I will just give the link where to download. So in my description as well as in my blog, https://nsnam.com, you can download it from there. So in any of this location you can download. After you download, unzip into a folder called as trace metrics, because it contains some values. I'll just show you now. So you can see here home, there's a folder called as trace metrics. Here you can see the trace metrics. Inside that I have a readme text. There's a library folder that have so many jar files, and we have a trace metrics.jar. So this file only we have to run, and using command prompt we have to run this file. Okay, so all these three should be in the same, the lib folder and this trace metrics.jar should be in the same folder. If you lib and these are in a different folder, the trace metrics won't open, it will throw some error. Okay, so now what I do is I'll just open the trace metrics, cd trace metrics java -jar trace metrics. So this is a trace metrics software, and this is the window it opens. Go to file, choose file, then I use ns all-in-one ns 3.27, and we have a file called as first.tr. Please see the location of this file. It will be in the ns 3.27, but trace metrics are in a different folder. Then you open. So now it will tell you first.tr, what is the total size, what is the time modified, what is the path, read, write and execute. So execute analysis. So this is how it is going for execution. Now it will tell you that lines on file is 6. We have already seen that there are totally 6 lines. Total enqueued packets 2, total sent packets 2, received packets 2, no dropping of packets. Total simulation time this second, time of analysis 0 seconds. Now nodes. If you want to know about a node, you can click it. So sent packets 1, received packets 1, and node number 1, sent is 1, received is 1. So it will show you some value, and there is a value called Little's theorem also. So you can find out the value of Little's theorem to get some information on networking. And here throughput and goodput. So we have node number 0, the throughput is this and the goodput is this. And again we have node number 1, throughput is this and goodput is this. So goodput means the useful data between the node 0 and 1. Throughput means the complete information about the packets per second in the network. So a little result in this lambda value is somewhere is then. I'm not sure about how they calculated it. Maybe if you want to have some parameters, you can please verify the literature. The last thing is streams. In streams we have UDP. So all stream, so how UDP packet goes from stream 0, how it goes from which node to which node, which port number to which port number, how many packets have been sent, like this. And you will get this link also enabled. Maybe this example doesn't show that, but in another example this line will be enabled, this button will be enabled. Once you open this button, you can plot some characteristics using GNU plot. So for that you need to have GNU plot also to be installed. Maybe in the second example I'll show you how to use this third option in trace matrix. So in all these examples, okay. Also I will show you Wireshark also in the second example, because in all the thing in the basic example may not be apt enough. So I will show you these things on the next example. Okay, so first .cc is done. So to open this file, cd trace matrix, then java -jar trace matrix .jar. This is the command to open the trace matrix. So after it is done, we have seen it. Okay, so thanks for watching my video. Don't forget to subscribe. More results will be in pipeline. More results and more projects will be in pipeline. I will share the code also shortly. I will open the GitHub account to share my codes. Till then, please refer https nsnam.com and my YouTube channel youtube.com/ts Pradeep Kumar. Thank you.